Okay, here we've got a BC ferry, 13,000 metric tons. So to convert metric tons to a mass, the mass of the ferry, we just multiply by 1,000. So it's actually 13 million kilograms. There's your mass of the ferry. Now it's originally traveling at 11 meters per second. Now just to keep it simple, I'm going to flip my little photo there and imagine the ferry is moving to the right originally. So its initial velocity is positive 11. We're going to say to the right is positive. Direction matters as usual. Now, the engines produce a force of 1 times 10 to the 6 newtons, 1 million newtons, for a period of 20 seconds. Question A asks for the magnitude, which means I don't worry about the direction, but I'm going to have to eventually, the magnitude of the impulse. Well, we know force, we know time. That's our easiest way to do it. Impulse is average force times time. It is directional, and we'll talk about that in a second. And we put the numbers in. So our force, they say, is 1.0 times 10 to the 6 newtons. And that acts for 20.0 seconds. And when I multiply those two together, I get an impulse of 2.0 times 10 to the 7 Newton seconds acting on the ferry. Now that's the magnitude of it, but what's the direction? Well, the engines are put in reverse, so it's causing the ferry to slow down, and an impulse is in the same direction as your force. So please remember that your impulse in this question is causing the ferry to slow down, so it's actually directed that way, to the left. So my impulse should technically be negative, the way I've drawn my picture. So my impulse is to the left when it acts on that. Keep that in mind. Question B, what is the new momentum of the ferry? Well, we also know that impulse is change in momentum. And change in momentum is simply P final, which is what we're looking for. What is the final momentum, the new momentum, as a result of it slowing down, minus P initial. So there's my equation. Impulse is change in momentum. Now P final is what we're looking for. P initial is, I'll just fix that little negative sign there. P initial, we just go mass times velocity. Well, we know our mass, 13,000 tons, which is 13 million kilograms. And I've stated that its initial velocity is to the right. So I'm keeping it as a positive 11 meters per second. Now the trick is my impulse is to the left. So my impulse is actually negative 2.0 times 10 to the 7 Newton seconds because it's slowing down that vessel. So when I do the math, I'm going to take 1.3 million and multiply it by 11. And whatever that is, because it's subtracted on the right, I'm going to add it to my negative number on the left. So my answer looks like this. Negative 2 times 10 to the 7 plus whatever, 1.3 times 10 to the 6 kilograms, 13 million kilograms. I think I've said it wrong a couple of times here. All of that will equal P final. And when I work it out, I get a final momentum that's positive, it's still moving forward, of 1.23 times 10 to the 8th kilogram meters per second. Now, one way to check is to see if your momentum has increased or decreased. So figure out what your initial momentum was before. So 13 million times 11 gives me 1.43 times 10 to the 8th. So I'll put that in red above just so I can make heads or tails out of all this. My initial momentum, when I just go mass times V initial, was 1.43 times 10 to the 8 kilogram meters per second. And because the engines were put in reverse, it makes sense that my momentum has reduced to 1.23 times 10 to the 8th. Now if we want to know the new velocity, I have one step left. I know the final momentum. I just set it to mv. So P final is mv final. So 1.23 times 10 to the 8th kilogram meters per second equals my mass, which is 1.3 times 10 to the 7 kilograms times V final. And when I work that through, I get V final is 9.5 meters per second. And it's still, in my picture, moving to the right.